Okay, so this tutorial should help you answer the quiz that you did in class on gases and atmospheric chemistry. So the first question asks you to tell me the difference between solids, liquids, and gases based on these four components of the kinetic molecular theory. So how I would answer this question is I would set it up in a table to keep myself organized. And it asks you to tell me the difference between the space between particles, the speed of their movement, their type of movement, and the energy of their particles. Okay, so if we take a look at this, the first thing it asks is about the space between the particles. In solids, there's very small spaces. Liquids, we know there's a medium amount of space. And in gases, there's very large spaces. That explains a lot of things like their density. Okay, speed of movement, we know solids move very slowly. Liquids, again, are somewhere in the middle. And gases move very fast. Okay, and we know that's how their particles are moving. In terms of their type of movement, solids are only at vibrational energy. Liquids, though, can vibrate. They can show, I should say vibrational. They also show translational energy or movement, so that's moving in a straight line. It's just vibrating. And last one is rotational, so they can rotate in a circle. Gases also can show all three. In terms of the energy associated with the particles as well, we know solids have the lowest. Again, liquids are somewhere in the medium or middle, and gases have very high energy. In terms of marking, this question would be out of 4. You would get a mark for just talking about each of the 4 comparisons. Next question is talking about a balloon in 2 different scenarios. So one where it's under a certain amount of pressure and temperature, and another one where it's in a new amount of pressure and temperature. So because we're talking about 2 different scenarios, we know we're looking at our combined gas law. Okay, because we're talking about the same balloon in 2 different places. Before we can use this formula, though, we do have to do some conversions. Okay, so both of these temperatures need to be converted into kelvins. By adding 273.15. We're going to do that for both. And for kilopascals, this atmosphere needs to be converted into kilopascals. And we know kilopascals is atmospheres times 101.325. And because we have 1, we're going to end up with exactly 101.325 kilopascals. Okay, this question's out of 5. Your first 3 marks would actually just be for doing these conversions correctly. Your 4th mark would be for showing your formula. Now we just have to plug all these numbers in. So our first pressure was at 1 atmosphere, which we converted here. Our first volume is given to us in the question. Our first temperature we converted over here. Our second pressure is given to us in the question. Our second volume is what we're calculating for, and our new temperature was calculated over here. Okay, so to get rid of this, we multiply both sides by that. And to get rid of this, we're going to divide both sides by that. If you plug that into your calculator, you should get a volume of 2.5 times 10 to the 2 liters. We've done that because we need to reduce it to 2 significant figures. So that's going to be our 5th mark. In this question, some information was added that the gas was CO2. That's going to help us answer the question. So because we're only given one set of information here we're using PV equals nRT. Okay. While we're filling this out, our pressure is in kilopascals, which is what we need it to be in, so we don't have to convert that. Our volume is given to us in the question. Moles is what we're trying to figure out because eventually we're going to figure out mass, and we're going to use moles to figure out mass. R is always the same. And temperature, we need to convert from degrees Celsius into Kelvin. So we know, same way we did it before, Kelvins equals degrees Celsius plus. Which works out to be 360.15 kelvins. We're going to plug that in. Okay, so we need to divide both sides by 8.31 to get rid of this. And divide both sides by 360 to get rid of that. So our moles of gas works out to be about 0.012, some more decimals. And now that we know the amount of moles, it's easy to figure out mass, because we know mass is just moles times molar mass. So we're going to take the number we just calculated and multiply it by the molar mass of CO2, which you can calculate using the periodic table. And because we only have 2 significant figures for all of our units, we're going to reduce this to 2 significant figures. So this question would be at a 4. You get a mark here, a mark for showing your formula, a mark for calculating moles, and a mark for calculating mass. On the back, important piece of information given here is that it tells you that it's at STP. So we know we can use molar volumes here because the pressure and temperature stays constant. Okay. So here we know moles is volume over molar volume. Okay. We know how many moles we have. We have 4.5. We don't know the volume, but we do know the molar volume. Okay, so to get volume by itself, we're just going to multiply both sides by 22.4 liters a mole. So our volume works out to be 1.0 times 10 to the 2 liters. Again, we had to put it into scientific notation because we only have 2 significant figures. This question would be out of 2. You would get a mark for your formula, a mark for your final answer. Next question is really the same, except instead of being given moles, we're given mass. So we have to convert it into moles first. But we know moles is mass over molar mass. That's back from unit 2. So we're going to take our 56 grams and we're going to divide it by 32 grams per mole, which is going to give me 1.75 moles. Okay, we'll then do the same calculations we just did, because now we know moles. Okay, and again we're going to multiply both sides to get rid of this. So our volume is going to work out to be 39.2 liters. We know that 3 significant figures is what our final answer should be in. This question would be out of 4 marks. You would get a mark for this formula in calculating your moles. You would also get a mark for this formula in calculating your liters. The last question is a stoichiometry question. Okay. A few more pieces of information were given to you about the chlorine gas. We were told it's at 25 degrees Celsius. It's 25.0 degrees Celsius, actually, for significant figures, and 2.75 kilopascals. Okay, so we're going to set up our table. What information is given to us in the question? Okay, we know our mass is 75 grams. So from that we can figure out moles, because we can look up, using the periodic table, what molar mass is, and from that we can figure out moles. Okay. Also now, just like Unit 2, we can use that information to figure out number of moles by using our mole ratio. Okay, so we know how many moles of our organic compound we have, and we're going to multiply it by 2 over 1, so that'll give us this many moles. So that's how much of this we have. Okay, because we are given a unique temperature and pressure, we can't use molar volumes, we would have to use ideal gas law. Okay, but we're told our pressure. We're trying to calculate our volume. That's what the question asks for. We know our moles. We just calculated that. We know R because it's always the same. Temp, we know, but we need to convert it into kelvins. Which is 298.15 Kelvin. So we'll put that in here. Just run out of room. We're going to divide both sides by 2.75 kilopascals to get volume by itself. And if we put that into our calculator, you should get 805 liters. And we're reporting to 3 significant figures because this has 3, this has 3, this has 3. This type of question would be out of 6, let's say. You would get a mark for molar mass and for moles. You would get a mark for doing your mole ratio calculation. You would get a mark for converting to kelvins. You would get a mark for this equation, and you would get a mark for your final answer. So hopefully this helps you prepare for the quiz coming, your unit test coming up.